we have 2.6, scatter plots and best fitting lines. Anybody remember what a scatter plot is? Bless you.
A whole bunch of plots on a graph.
Okay, a whole bunch of dots on a graph. Are you okay? Okay, so.
Oh,
Okay. When would I make a scatter plot? I don't know.
when you get a whole bunch of points on a graph?
When you get collect data points. What's that? Yep, that's what it is. What we're going to do today is we're going to check for correlations. What a correlation means is if I plot a bunch of points and they look like they are following, now it's not going to be exactly a line, but if they're close to following a line, then they have some kind of correlation. In other words, if I look at this graph, as x gets bigger, what appears to be happening to y? It's getting bigger, right? When x goes up, and I move over here, y appears to be getting bigger as well. When you look at a scatter plot, and it looks like the dots are generally increasing, getting taller on the y-axis when it goes further on the x-axis, we call that positive correlation. Now, if my scatter plot looks something like this, as x gets bigger, what happens to my y values? It's decreasing. If I were to draw a line that went through that, what would be the slope of that line? Would it be, what would you know about it if it's decreasing? It'd be negative. So since the slope of the line would be negative, we call that a negative correlation. Now, if I plot a bunch of points, and they look something like this. There's no correlation. If it doesn't appear that there's any pattern there, as x gets bigger, y gets bigger, or as x gets bigger, y gets smaller, then we say that is no correlation. Who might use this?
Josh. Honest Madison.
How about in the real world?
People, like, amazing people, like,
Amazing
responses,
people.
whether they get, like, positive or negative, whether people like that article or not.
How about out at the research center?
Well, that's
Of course.
When they, what's that?
when you're recording vitals.
Yes.
No.
You're recording information about a series of patients. When the patient has blood pressure of such and such, their heart rate tends to be this. Or when a patient has high cholesterol. Have you heard if you have high cholesterol, then it increases your chances of a heart attack? You may have heard, well, those.
Eat Cheerios.
That is exactly where this gets used. They collect a bunch of information, then they compare the two data points to each other, and they say, well, if it looks something like this, as cholesterol gets higher, the incidence of heart attacks gets higher. They say it's a positive correlation. So that's where they get those numbers, is exactly this kind of thing.
Subscribers might also use it.
What's that?
Cell phone subscribers.
Okay.
It says in the book.
Yeah, you're right. You're right.
What'd you say?
Cell phone subscribers.
Cell phone subscribers.
Oh, those are fun.
Okay, so now get out your ruler. We're going to plot some points.
It's a big number. It's right in.
Get this. Oh, come on.
Oh, double day. Oh.
Ah.
Oh.
There we go. No, I'm
Oh, there you
supposed to
go.
be erasing data.
There you go. Good job, Miss Raymond. You're a fantastic
What would I do
job.
without your encouragement?
I
John?
don't know. Might not make it through the day.
I might not. I kind of enjoy it. Okay. So, we're going to plot these points. Now, the x values are easy enough. They go 1 through 7, but they are 0 through 7. So this is going to be my x-axis. We're going to start it clear down here. 0, 1. I'm only going to label every other point. 4, 6, 8. So that's going to be my x-axis. Now my y-axis over here is a little bit trickier. I need to decide what kind of a scale I should use on this. And we're actually going to break, we're actually going to start at 200. When I look at that, if I go from 200 to 548, let's count by 25s, okay? Each little square is 25. So that means if I skip one here, this will be 250. This one will be 300. That'll be 350. 400. 450. 500. 550. That's enough. Okay, how did I figure out what kind of a scale to use? Do a
Because
little-
you're the teacher.
How can you figure out what kind of scale to use?
Because there's numbers that go all the way to 500.
So yeah, you see, no, you're not going to want to count by lines. Right. So if you look at that, you see how much space you have, and say, okay, if I count by 5, that's still not going to be enough. So you kind of want to make some adjustments, but you want to use as small a scale as you can, because if it gets, let's say if I counted each one of these by hundreds, I'm not going to see much difference. So you kind of have to adjust that. So let's plot these points. I have the point 0 to 80, so that's going to go right there. And you do not have to label these points, by the way. 1 to 95. 2, 322. It's almost at 25. 3, 395. 4, 425. 5, 471. 6, 511. 7, 548, almost 5. Should look something like that. I'll give you a minute to get that picture made there. Okay, you're going to get your ruler out again. As soon as you get those dots made, what I want you to do is lay this ruler on those points in such a way it looks like it goes about through the middle of it.
Hey, Miss Redmond, can we trade rulers? I like the big one.
No.
You can have the little one.
Sorry. This is mine.
All right. Yes.
So, when you lay your ruler on there and draw a line, it should either be, the idea is there's as much distance above the line as below the line. So I'd say about there. Now, is this an exact science when you're just doing it this way?
No.
No. Everybody's going to have something a little bit different, and that's okay. So when you do that, once you get that done, what I want you to do is look at your line and pick 2 points that are the closest, that appear to be pretty much on the line. That one looks pretty good. This one looks pretty good. Okay, again, depending on what your eye tells you, it could be a little different for different people. So the 2 points that I chose were the point, this one right here, 7,548, and this one right here, 4,425. Okay, so I want to write an equation of that line. I have 2 points. If I have 2 points and I want to write an equation of the line, what do I need to do first? Slope. You need to find your slope first. So I'm going to write M equals y2 minus y1 over x2 minus x1. So I've got 548 minus 425 over 7 minus 4. So let's see. 123 divided by 3. Okay. Well, that works out nice. That's 3, that's 41. Or 41 over 1. So that one came out even. Now, not all of these will come out even. You can write these in decimals today. If you get a decimal, I want you to write it 2 decimal places. Nearest 100. Okay? So, now I want to write an equation, remember. I have my M. Pick either point. Let's say that. Okay, so I have y minus y1 equals 40, or M, write the equation first, times x minus x1. So let's plug in values. Y minus 425 equals 41 times x minus 4. Okay, so 41 times 4, I get 41x minus 164. And y minus 425 equals that. Add 425 to both sides. And I get y equals 41x plus 261. Okay, there is the equation of my line. Now again, is everybody going to get this exactly? Not when you're estimating. Okay, so you do them by hand. Now, I've had another question. Let's say I assume that my x values keep getting bigger and bigger and bigger. I want to estimate when x equals 20, what would my y be? So if I go out here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 would be clear out here. So if I went up here, and this line kept going like this, it'd be way up here somewhere when it met up with that line, right? Okay, so what this equation does, well, let's do one we could do on the line first. Let's do 10. If I go up here on 10, ends on that line right there. If I extended my line out without moving it too much, and would intersect at about right there. Let's see, 550, 600, 700, somewhere around 750 it'd be 10, right? Well, let's check that with our equation. So to do that, I'm going to substitute 10 in for my x. So I get y equals 41 times 10 plus 261. 410 plus 261 equals 671. Well, my estimate must have been a little off. Which one's probably going to be more accurate? This one. Okay. Again, that's the second thing that scientists will do with the correlation. They have a small data set and they say, well, what happens is they say, okay, in these 3 years, something happened. They measure the population of hawks in a certain area. Well, the hawk population is decreasing. So they say, well, if I extend that line out, then in 5 years, they're going to be almost extinct. When you hear statements like that, that's the kind of things they're using. Now, if something else comes in and changes the situation, this doesn't apply anymore. It might change. But if everything stays the same, that says, well, that's the trend that's happening right now. So that's what those values mean. Now, the second part of today's lesson, you can do this on your calculator. It will do it for you. When your calculator does it for you, it's much more precise because it doesn't look at it and guess. There's actually a statistical formula that gets the same regression line, we call it, every time. So get your calculator out. I want you to push the stat button. It's in the second row, right close to the little arrows there. So push the stat button. Okay, the edit should be already highlighted. So I want you to push enter. You should have 2 columns, L1 and L2. Is everybody there? Okay, so in L1, if there's anything in there, just type over the top or delete them. I want you to enter all of your x values. So you're going to enter 0, 1, 2, 3, 4, 5, 6, 7. In L2, I want you to enter all the y values. Get it figured out? Just push enter. Okay. Oh, okay, so you're just going to have to enter. Just this way. Otherwise, did you get them all in there?
Yeah.
Now, this didn't match up with this. So something's weird. You gotta go back up here and start here and re-enter them. Type 280. Make sure when you get done with your list that the X up there matches with the Y up there. And they're right across from each other. So double check your list and you get it all in. Just got it all in. I'll be getting back here, guys.
Fantastic.
Looks like you guys got it.
Yeah. Josh is back here. He's gonna be a doctor one day.
Okay. There shouldn't be any extra numbers after the 7 or it'll mess up your regression. Okay, so everybody got their numbers entered. Then the next step is you're going to put the stat button again. Okay, now you'll see that there's calc at the top of the screen. Push the right arrow so that the calc is highlighted. Then you're going to push the down arrow. You go down to number 4, says linear regression AX plus B. Anybody not see that? Okay, once you see that, push enter. Now, once that's highlighted. When on the next screen, it should say linear regression AX plus B. Push enter again. Your screen should look like this. Okay, anybody not get this? You have an extra number there? Is yours not close? Okay. Yeah. Right here, I'll have a look out. Enter. Or no, sorry.
Yeah, I can
Down
get worse.
4.
Yeah?
Now
Like it's nothing or what? Yeah. Just a little, yeah.
Now, if you got different numbers than me, you probably mistyped a number, or maybe I mistyped a number. If you got the right numbers entered, and I think I had mine right, did anybody get the same one as I did? Most people get the same one? Okay, if you got the same,
I
then
made the same mistake.
okay, should be the same as this one. Like I said, if it's something different, you probably mistyped a number somewhere. Now, what this tells you is the linear regression line is y equals 40.87x plus 262.83. I'll leave that. Now, let's put in our 10 and see what it tells us it should be. So 408.7 plus 262.83. Not too much different than what ours did. Okay, when you answer your problems today, the first 2 you're going to do by hand. Well, not number 10 and 11 are going to be by hand. So you're going to plot the graph just like you did here. So on 10 and 11, I want to see the whole thing. You plot the graph, you draw the line, you find the slope, write an equation of the regression line, and they actually tell you to find y when x equals 20. Okay? When you get to 12, you can do it with your calculator. Parts I want to see on the paper are the regression line and the number when y or x equals 20. So there's 2 answers on all of them after the first 2 there. Okay, question.